Alright, so I have a negative exponent. The rule about negative exponents is that they belong under 1. So I'm going to make this y equals 1 over 5 squared. Y equals 1/25.
Yeah.
Well, all of them aren't fractions, though, right?
Alright, let's do number 2. So y equals negative 2 times 9 to the 1/2. Wait a minute. That's 3. I said yesterday. How do I do 9 to the 1/2? Well, this, I hope some little part of your brain is thinking of the radical form, where you take the 2 down and around. This is really negative 2 times the square root of 9. 9 to the 1/2, if I bring the 2 down and around, is the same as the square root of 9. So this is negative 2 times 3. The answer ends up being negative 6.
A bit much work, man.
These are called exponential functions.
Yeah.
This is a shorter way to do this.
You could just always rely on a calculator and not show mastery in the curriculum.
So this curriculum is basically about calculus.
No, understanding what a calculator is doing. You can put this right in a calculator and it'll pop out negative 6.
But if I don't show it, then
Well,
I don't.
so your calculator is really hard to use.
No, not the ones they use in
Actually,
college.
the shoe calculator is so easy to put that in. No, it's like way better.
Isn't it the one? Not the ones with a lot of buttons. The ones with a lot of buttons.
That's 12.
Only because they
Four.
don't let you do that. They don't let you use that on the
Somebody got put on their neck.
I would only be hard to use.
They don't
They
get
don't
that.
show you. I'll tell you all about your calculator. Let's bring one down. All right, what's 3 to the 4th? Do you know how to put 3 to the 4th in your calculator? I'll show you that. I can show you that.
But Miss, why won't you just multiply first?
Because exponents come before multiplication. One of the big things that you were supposed to get yesterday. Do the exponent before you multiply.
But it'll still be the same.
No, what's the answer there? 81.
Miss, aren't we gonna have to test on this?
324?
Yeah. I just got to figure out when. This ain't clicking in my brain.
Oh, that's 43 mil.
Huh?
You did 12 to the 4?
Oh.
See?
Or you need to.
No, doing 12 to the 4th, I got 20,000. I'm stuck in something. Oh, I know that they wrong. Never mind.
Alright guys, before we check yesterday's assignment, I want you to take some notes on chapter 6.3. So directly under your bell work, you're taking these notes. Exponential functions are nonlinear. They make this, it's a half curve. It's a half curve. You don't have to write half curve, but. And we're going to try graphing one exponential function right in your notebook before we go to your textbook. So we're going to graph using a table.
Okay.
Miss, can I
First,
take
we
a
use the
bathroom?
bathroom.
Miss, can I?
No, we're doing this right before school. This is after school.
Wait till after school. Oh no, my brother can't do it.
Alright, so we're going to make a little graph of this little guy. Just show the expo. It's called exponential function because the x isn't down low, the x is an exponent. And that's kind of fun. Fun and different. It's also fun and different that we're finally doing a non-linear line. We're doing a curve. Fun and different.
Yes, this is
Fun and different. So we're going to use this basic table, -2, -1, 0, 1, 2, and we're plugging in for x. So this would be 2 to the -2, 2 to the -1, 2 to the 0, 2 to the first, and 2 squared. I don't want to get ahead of you. I feel like doing it. I'll pause.
yes, you.
Laura, did you finish your table? Go ahead and finish the table. As far as I know, nobody is done. Nobody's.
I'm paused. I put on pause so that you guys don't have to go back.
Yes, I got my table finished.
My neighbor just left.
So he switches schools every year. Miss Alex is rapping now.
That's crazy because I'm having another student he was a leftist.
How are you gonna know how to make this beautiful graph? I should have root class.
Now I have regret. Alright. 1/2 squared, 1/4, right? So 2 to the -2 is actually 1/4. Are you okay with that? Jason, are you with me? 2 to the -2 is actually 1/2 squared, which is 1/4. So that means I have an ordered pair at -2, 0.25. That's my first point. Did somebody already go? Does anybody see the purple pass back there? Well, I guess you can't go. It wasn't meant to be. Yeah. Oh, you found it?
Yeah.
Wow. What's 2 to the 0? 1. So we get 0, 1. 2 to the first I know is 2. 1, 2. And 2 squared is 4. Too much? I'm just excited. I absolutely love this graph. Yeah, graphing it. This is graph using a table. The whole purpose of the table is so we can make a graph. It's okay, guys. It's just one little graph. We're gonna graph in your book, and they give you. Well, I guess if you have graph paper, you want to get it out. What are you confused about so far? Like, you've made a table. You've plugged in for x before. Is it because x was an exponent? Yeah. Oh, for Bauer? Oh. I'll take that. That's accepted. Let me know when you're ready to start plotting points. Okay. So my first point is at -2, 0.25. That's kind of weird. How do I do 0.25? So here's -2 and here's 1. So 0.25 is just a little bit above the x-axis, like a quarter of the way up. And then -1, 0.5 is just like halfway up. Okay? You're kind of floating. And then 0, 1. Right behind. Oh, okay. I've been confused about that too. Page 513. And then it's 1, 2, and then it's 2, 4. So you can see the curve. That's what I like about it. So when you go to connect your dots, you don't randomly do it. To be honest with you, this graph is kind of weird. It never goes below 0. Some of them do, but this particular one never goes negative. So I'm going to start like really close, and then I'm going to move through the points, and I'm doing it not with pointy lines, but with curved intentions. It goes up really high, and it goes that way. And that is the half curve, and that happens every time x is in an exponent spot. When x is a regular spot, you have a slope and a straight line and rise over run. But when x is in an exponent spot, it's cool, it curves. One way I would describe this is that when I look from left to right, this graph is increasing. It's increasing. It's going up very quickly. So there's this really cool word for this moment on this graph where I said it never goes negative. I'm going to make a dashed line here, and I'm going to tell you a new word for this. This dashed line, where y equals 0 is called an asymptote. An asymptote. Asymptote. New vocabulary word, asymptote. Asymptote is a line that a graph will approach at the end but never crosses. Actually, it crosses in the middle. Towards the end on the left side of this x-axis, the purple arrow gets really close to the asymptote, but it never touches or crosses. Which is kind of weird. Like, why won't the graph ever be negative? Why won't this graph ever be negative? Let's think, but why doesn't it numerically? Why wouldn't it go below 0? When I put negative non Tell me why this will never be negative. What can I put in for x right here that would give me a negative? Like I just got decimals. Why can I get a negative y value, please? This equation will never be negative because every time I put a negative x in, it just makes a fraction. Negative exponents are not negative numbers, they're fractions. So because my x value is an exponent, even when it's negative, the result is still positive. This table will always have positive y values. That's very different than a linear concept. All positive y values because negative exponents are fractions. Pretty crazy. Now I could move this around. Maybe I'll show it on Desmos. I'm going to. Alright, you guys are just going to have to take my word for it. This is a real bummer. You're just going to have to trust me. So, let's say, for example, I was going to do this 2 to the x, the same exact graph that we just made, but I put a plus 5 at the end. How do you think that would change the graph? It would move it up 5. So here's the original, the one you just made, and then here's the up 5. Right? You guys fine with that? You're adding 5 to every y value. So what if we did y equals 2 to the x minus 5? It would go down 5. You okay with that? If you go down 5, the asymptote moves. The asymptote is now y equals negative 5. That bottoming out moves with it. Okay, it went down 5. Sometimes students, they learn this and they think the graph never ever crosses 0. But that's not true. If you put like a minus and you move it down, then that bottoming out moves down like this. The dashed line will be here at 5. Okay? One more. If I put a negative sign in the front, same equation but a negative sign in the front, what will the graph look like? No. You guess so. Keep the guesses coming. It won't. What do you mean by that? It'll flip it. It'll flip it. So with the negative in front, it looks like this. And this one never goes positive. Every y value is negative. Okay, because the negative is front. Okay? That's just an introduction. This is on chapter 6.3. We're going to be looking at more graphs in your book. But right now I'm going to check your homework from yesterday. So get out those problems, 7 to 18. Alright guys, 7, 8, 9, and 10. 7 is linear. 8 is exponential. 9 is exponential. And 10 is linear. Did anybody get all 4 right? Well, I'd like you to specify exponential if it's going to be multiplication. No, not today. Tristan, this is your first day back. When?
Oh, we have the second book. You just have to find your letter.
Alright, let me show the rest of the answers. Here, that's 4. The last 2 I 9, 3 over 2, negative 172. Infinity, I have it on the other.
Wait, no.
Right now.
Yeah, right now. Was it the classwork?
Yeah.
I'll do that.
Do you want to show me the handout from yesterday?
Handout? Yeah, I sent you that. Wait, what handout?
It was the voice worksheet last Friday.
32 questions.
Past 32 questions. Half of it, I couldn't do the rest.
And you'll show 16, 17, 18,
I'll do that.
14 is 8. 14 is 8. 8. Here's 16 and 17. Also, you
So what did you get
And here's 18.
Oh, Jesus.
Alright, let's start today's assignment.
Huh?
Yep. I don't know, it's just like the next page. What page is it? On the same page. What, 514?
This is the assignment.
Oh, that ain't much work to do. It's not much. Yeah. Y'all like. We're supposed to start like yesterday. Oh. Dude, guys. Hey, did you double baby tape?
I think we should do 20 hours of that.
What? What page is it? Wait, what page? Oh, okay.
We don't have.
Yeah, there.
No. I'm sure. I'm like 5'7",
That was so random, but I had to say it. I don't know how to.
I find that different. You don't have the rules.
Okay, so that example is exactly what we're gonna do in 21 and 23. -2, -1, 0. Yeah, and then you just like you see the 2 on the y side, you're just gonna put a. No, not for back, the back. I'm talking about the back. That's what we're gonna do technically. And then for the front, I don't know. I guess we're just gonna do the same. I know.
I say that.
I just want to okay, well,
Yes, we want to do that.
no.
One. Or like that.
It's just different people. It's like people. It's just that.
I don't even know how to do this.
No, I don't know how to do 19 and 20. I did number.
As with you two.
Wait, there's an example right
Yes.
here.
We
out of nowhere, I'm walking, I see her behind me. She goes and kicks my ass with her jersey free shoes.
Whatever helps.
Literally, literally, literally. Literally.
Now I can't, bro.
Who uses that word anyway?
Oh, really? Nobody. I thought
It
that's
was
what she
just
called
a
you. I thought that's what they called you. Becca. Then all I said is Becca, and then she does that.
Consistently here. Let's do this.
Becca. What's that?
Yeah, no, but then you have to like
Listen to her. Her accent. I'm trying to learn. You can't teach the new accent.
And that's how you.
Always people listen. Yeah. I mean, I mean, like half on the outside.
You guys, I said y'all have it done in like 10 seconds. Am I already ahead of you?
No.
Be quiet. Do you guys know that I found 3 textbooks, issued 3 textbooks, wrote a pass to a student and answered several questions, and came up and did a problem? What have you gotten done?
Well, Miss, you is properly trained.
Could you please train yourself to hustle a little bit? Did you get anything done yet?
I did.
Did you make this picture?
Yes, I did.
Okay, I'm happy.
Okay.
Number 20. How am I going to do 20? You guys might do 20. One thing I noticed that these are all negative.
Also, it's gonna be flipped around.
Also, these are going to be kind of off the graph. Like, it's going to be really difficult to get to 200, right? So, the thing about nonlinear graphs is that it can be very difficult setting up the y-axis. So, let's just try. Our x's go from 1 to 7. So, I'm going to go 1, 2, 3, 4, 5, 6, 7. And then our y's, let's say I go by -3, -3, -6, -9, -12, -15, -18, -21, 24. Finally, I made it to -27, and then I'm going to stop at -30. So I'm in point 3. So 1, -1/3. 3, -3. 5, -27. 7, -243. I'm just gonna put it like way down low. Sharika, do you see a similar curve? Okay. So I have in this 45-minute class period, I just sketched this and told you how to.
Yes, you just made the calendar pop up.
Okay, thank you.
Ooh, first day of Black History Month. Later.
Okay, my bad. Okay, so for your notes, you guys, I named the function. I drew a sketch, said it was a half curve. You made a table. You yourself made a half curve, right? Over here, I explained we've copied 2 more half curves tables. So by my calculation, you've done it 3 times, and I've shown you about 6. When you leave here today after this 45 minutes, this is what I need you to know. If x is an exponent, the graph is a half curve. Did you take that away? If the x is an exponent, the graph is a half curve. The x is an exponent, match it with a half curve graph. Okay?
This is such thing as a full curve.
Well, you make a circle. It's called a
Can you
convection.
make a circle on the graph?
It wouldn't be called a function because it wouldn't pass the vertical line size, but I do know how to make an equation and graph a circle.
Won't we have to know that like later in life if we go to college?
Pre-calculus.
I ain't looking.
That's not an option in college if you like do like you want to be a scientist or something, right?
All right, I got 2 more. 21 and 23. Let's do it. That's it. That's all we gotta do. 21 and 23. For both of them, you guys are doing the same table you did up here. You guys are doing this table x, y, -2, -1, 0, 1, 2. You're putting it as an exponent. If you want to make it a decimal so that you can make a graph, fine. Yeah, whatever. So this is 8 to the -2, which is 1 over 8 squared, which is 1 over 64, which I don't even know. Can someone get a calculator and divide 1 by 64?
That'll be 1. Yeah, that's like 1 over 2, which will honestly be 1 equal, which will be a half.
Who's got the correct technology out? What's 1 divided by 64? Yes, sir?
Like you are using that phone. That's his problem.
I'm not using my phone. I just use my brain.
How about 1 divided by 8? Okay, a little bit higher. Very good. And what's 8 to the 0 power?
Yeah.
So here's my ordered pairs.
So we could talk about what time it is.
It's 2:19.
You just told me Sure, can you get a new phone?
Yes. So eventually I'm gonna, I don't even know if I can, but if we were to move this up, down, left, right, we might talk about a different table, but for now, yes.
Yeah, that's
I can press with a home button. Huh?
Yeah, I'm up. I'm back up now.
Oh, what kind of phone you got?
My 12. I have a screen fix. That's already checked. So
You always breaking a phone. You know for breaking a phone.
It only takes like a couple of minutes, a couple of hours.
Couple minutes.
Hours.
Mine only took a couple minutes.
So fix the string.
Yeah.
Wow. 0.01 is so close to 0. I'm uncomfortable not putting it at 0, but it's not 0, so I'm just gonna put it right above 0, right?
That was so much understand nothing you just said.
Look at the dot then. Just take a look at it. Is it right on the line?
No.
No, it's a bit above it. Because it's not exactly 0. It'll never be exactly 0. Mathematically, it's not possible. It's a decimal on purpose. Don't put it right on the x's, put it right above it. And now 0.1 is just above it a little bit more. Does mine look a little bit higher?
Yeah.
Yes, it does. That's precision.
I thought anything was possible.
0.18.
How is it possible?
Boom.
Who sprayed some perfume?
That's not perfume. That's lotion.
It's strong.
You smell it?
Yes.
Wow. This looks just like the other ones. It really does. It really looks just like the other ones.
I got the eyes. You mess with the eyes?
Yeah, is it starting to seem kind of easy now? Okay, good. Mission accomplished. The next one I think is difficult. It might be negative.
Girl, you're choking me with your lotion. Bro, I have allergies.
Choke.
She said choke.
Choke.
That was fun. Yes, I do. Yes, I do. It's on all my medical papers.
Hey, at least I'm not worried about the type
It's
of
36 trillion.
I'm gonna say
Hey, let's go. I'll get that.
because I know
I just got me a
Well,
child.
hey,
Over
dude.
Cambridge.
Baseball tryouts start Monday at 3 o'clock. Softball tryouts start Monday at 2 o'clock.
Is that a new one?
All three bus changes, bus 1092, right 683, 1013, right 683, 1035, right 642, 1035, right 684, 1082, right 684, 1082, right 684. Faculty and staff, those of you who are crossing the parking lot, exit from baseball field, may enter.
Oh, let me get that. Missy part in the front.
The announcements run.
It was going off when I actually was part in the front. They just say you had to leave early.
I did not say leave early.
Just stay
They said exit by the baseball field.
Where else was they going to exit?
You can exit out the back, like just go
But
straight.
that's closed. Yes, it is. They close it when the buses get there. Yes, they do. I'm being so dead serious.
No, not that yet.
When you get to the curb, though, they close that right there. Buses don't come through. I know one thing. It's a PBA charging $10 a car.
If you have a negative exponent, you put it on. So 8 to the negative 2 has a negative exponent. So you put it on.